In this video, we're going to examine the surface area of prisms and pyramids. It's basically taking a three-dimensional object, an object such as a rectangular prism, something with a height, a length, and a width, 3 dimensions, okay, or as a pyramid, which also has 3 dimensions. It'll have a height, and then kind of the length and the width of the base, and figure out what would be the area of each of the sides. So here we'd have one side, a second side, a third side, a fourth side, and a fifth side, and then a sixth side underneath. Okay, of the pyramid, we would have the front face, the 2 side faces, and then we'd have the back face, as well as then the base. So we'd actually have 5 different sides to calculate the surface area. Let's take a look at a brief video to show how we would take the Staples box and disassemble it into what's called a net. Basically, it's a flat object that we're able to label and to calculate. Such as so we have our Staples paperclip box. Cut it up just to be a little bit more to help with the unfolding of it to form the net. So I have the binder clips box. Okay. So this right now is showing 3 dimensions. I've got a height, I've got a length, and I've got a certain width to the box. Okay. So there's 3 dimensions: the width, the length, and then the height of the box. Okay. When I want to start looking at surface area to say, okay, how much cardboard do I actually need? It's important to take this, in a sense, to unfold it to form what's called a net. Okay. So what I would need to then calculate, I'm going to turn it like this just so it's a little bit prettier. What I would need to say is, okay, what's the area of the rectangle that forms the lid of the box? Okay. Each side of the box, and what would be the surface area of the base, okay, of the bottom of the box. So if it's 3-dimensional cube, okay, what that means is I've got 1, 2, 3, 4, 5, and then 6 sides I actually need to calculate the surface area of. And so my net might look something like this. Okay. Well, the key is then to figure out what is all the lengths. So for example, this would also be 6, this would be 6, this would be 6, this would be 6, because they would all have to have the same width as the box, say of 6. Okay. Anything that would show my height, 3. Okay. Basically anything being unfolded around here. This would also be 3, this would also be 3, this would be 3, this would be 3, this would be 3, this would be 3, and this would be 3. And then anything that would have to go with my this width of the box would also then need to be labeled as 5. So when I start to look at surface area, then I need to figure out, okay, well, what are the area of each of these boxes? This top box would end up being 6 times 5, which would give me an area of 30. Okay. This middle box would be 6 by 3, which would give me an area of 18. The middle box here would be 30 as well. Outside would be 15, this would be 15, and this would be 18. I would need to add these all up together. And if I were to add these all up, I'd end up with 26. I would have 116, and it'd be square units. Okay. So this is one example. Once you have the shape, okay, the 3-dimensional shape broken down into its net, its 2-dimensional representation. Okay, as you saw me with the staple box, kind of just sort of cutting it out so that it all laid out all flat. Okay, it becomes pretty easy then to figure out the surface areas of each box once you get the once you get the measurements all taken care of. Okay. For a pyramid, it's a little bit different to get the net. Picture there being almost like a lock right up here, okay? Where if I have the square base, okay, or rectangular base, and then I take this top part and sort of undo it and let each of these four sides fall. I would have one triangle here, one triangle here, one triangle here, and another triangle here. Okay? Because each of these faces would end up being triangular. And I would have one in the front, one on the side, one around the back, and one to the left side there. Okay? From there, I would need to figure out then the measurements. So for example, if I knew this was a square base where each of these were 5, and let's pretend my height might have been 6. Okay, so that's going to be my height for each of these. Okay, that means for the square base, my area would be 25 units squared. And then for each of the sides, each of these triangles along the side, I would have the 5 times the 6, but then I would have to divide by 2. So it would be 30 divided by 2, which would be 15 units. So this would be 15, this here would be 15, this would be 15, this would be 15 as well. Just because of the square base, they all have the same dimensions. So I would need to do what I needed to do with the prism, and I would need to add up all the sides. So I'd have 4 times 15, which would give me 60 units, okay, square units, for the triangular side faces. And then the bottom has 25 square units for an area. So if I were to add those up, okay, I would actually need 85 units squared to cover this particular shape. Okay, hope this has been helpful for you. I think the most important thing is to remember that you have to get the nets. Okay, kind of have this idea of how many bases do you have, how many different sides or faces do you have to the shape, and then to draw it accordingly and make sure you calculate the area of each of those individual shapes. Okay, hope